Thank you, Mr. Chairman. So, as we said yesterday during the panel talk, I introduced the concept of industry of the future related to human in the loop, and this concept evolved from human alone in the loop to human completely out of the loop, and you have intermediary level. The first level is really human in the loop, and another level is human back to the loop when the autonomous system failed and asked for support to human. So, regarding my content, I will remind you some principles around responsible artificial intelligence, and my contribution here is to propose you a new feature for making artificial intelligence responsible. So, to do so, we have two concepts very important to develop: human artificial intelligence coevolution and shared autonomy. And after, I will detail what we call educable learning. And I will illustrate the feasibility of the concept, and at the end, I will propose you some conclusion and perspective. So, I do not want to detail all these principles, but mainly for national or international organisms that work on the responsible artificial intelligence. We have 7 main principles to be developed, and I was interested to gather some of them into the concept of educable learning process linked to responsible artificial intelligence. So we have, for example, empowerment of users, resilience of the system, and particularly resilience of users, explainability, traceability, and understandability. You know well this concept. Inclusivity linked to the principle related to without any discrimination between users. So we have to take into account minorities. And auditability, that I make a link with explainability because of human modeling and human understanding constraint. So regarding this principle, I remind you, resilience for us is the successful control of unprecedented scenario, and I'll focus mainly on a scenario based on web signal. I remind you that web signals are signals with low level of amplitude or low level of occurrence that are interpreted as not relevant, but that can announce you a risk, another situation. So it can be sometimes very interesting to study this kind of scenario based on web signals. Explainability, understandability, and traceability. On literature, we make a link of around this concept, a link with human artificial intelligence symbiosis and or human artificial intelligence team. That is to say, there is a couple of people, a user and your artificial intelligence support tools, and you make exchange on some interactions like a symbiosis or like a team. Inclusivity, empowerment, and auditability. I developed the concept of the all-inclusive design for human artificial intelligence system for all users, whatever your cognitive level, physiological level, physical level, social level, whatever. So it's very ambitious, but it is a concept. And of course, we develop both concepts, human assisted by artificial intelligence. It's natural for everybody, but also artificial intelligence assisted by human. Why? Because I think that human is also intelligent. So human intelligence, we have to focus on it, and it is the way of educator learning. So when we are speaking about human artificial intelligence symbiosis, if you are looking for this concept, ecological coevolution related to symbiosis include cooperative and competitive interaction. So in cooperative interaction between two decision makers, for example, a user and an artificial intelligence support tools, both of them receive benefits, okay? Or one of them receives benefit, but the other do not receive any negative impact. On competitive interaction, it's very interesting because one decision maker can receive benefit from the other, but also some negative impact, and the other receive negative impact to the first decision maker. So it's very interesting to look at such ecological coevolution principles because we are focusing on negative and positive consequences of interactions interpreted in terms of cooperation or competition. Human needs for transparency. Here we are speaking about human factors, cognitive factors. So I propose here two very interesting concepts. Situation awareness. Explainability requires situation awareness for humans. That is to say, capacity to detect, to perceive the current situation, capacity to understand the current situation, and capacity to anticipate the evolution of the situation. So, explainability, traceability, and auditability, that's why I gather these three concepts through the concept of situation awareness for detection, evaluation, and anticipation. And another concept very interesting is sense-taking, so how to make sense to the situation, and I make a link with understandability, that is to say, it's a relationship between the understanding with the content of informational support system. We find on the literature other kind of feature for human artificial intelligence interaction, so usability and learnability, so they are very well known. The last one, perhaps you don't know, but it's very interesting too, memorability, and we introduced it implicitly yesterday morning. It means, in case of taking over the control of the system by the human is supposed to be able to react and to understand the system and to use the system without relearn about how to use it or its functions. So there are some hypotheses, and I think we can study them. So we propose an architecture integrating, of course, educable learning process and both decision maker, user, and AI-based system. Both of them contain their own knowledge, so between both knowledge you can have convergence and divergence, we speak about inconsistency. We have task allocation between human and machine, and this task allocation needs communication system in order to know who is working, why is working, and what about the state of the process. So, regarding the task allocation, we have an output, an action to the process. The action is done by the artificial intelligence system, the user, and from the control process, you have a couple of input and output, okay? It's a vector, and of course, through the communication system, the AI-based system and the user are capable to know, to detect, to understand, and to anticipate the situation of the control process. So, regarding a feedback, based on the detection of inconsistency, we focus on two levels for educable learning. Knowledge discovery, okay, the ability to discover new knowledge, and knowledge updating. And this module is very important because if the user discovers a new way to use the system or to modify the knowledge of the artificial intelligence-based system in terms of the structure of the knowledge, the content of the knowledge, the meaning of the knowledge. So it's not so easy, but I propose you some solutions. So regarding human artificial intelligence and business context, interaction, cooperative, competitive interaction or cooperative interaction, and we know what about the allocation, the shared autonomy between human and machine, between artificial intelligence system or user. Here, you have to choose who has the authority to act. You can compete, you can receive some advice from the other, but you can, if possible, you are not agree about the proposal because the human factors, you think you can better act than the other. For corporations, okay, you realize both the task or there is only one that acts on the process, but you can be assisted by the other in parallel. So after showing you this kind of configuration of interaction based on the consequences, I want to make some more detail about knowledge discovery. It is a part of educable learning process. So we have two processing, knowledge processing. First one is based on natural human reasoning, and here. So we have to make a link between the input and the output of the control process regarding your own model. So we can speak about the cognitive model, but this cognitive model can be implemented into artificial based intelligence knowledge. But here, okay, I want to simplify. So we have the reasoning, deductive reasoning. That is to say, if you observe an input and there is a relationship between an input and an output in your knowledge, that is to say, you can suppose that the output will occur. Adductive reasoning is quite the opposite, but if an output is observed and you have a link between input and output, that is to say, it's possible to observe the input. Okay. And regarding the experiment based on natural human reasoning, you have inductive reasoning, that is to say, regarding your experience or regarding the training process of an artificial intelligence-based system, you observe a couple of times the same event and the same relation between this similar event with output, that is to say, you can produce a generic rule, a generic relation, a generic link between input and output. And counterfactual reasoning, that is to say, if you have some event occurrence and opposite rules are said to you, there is a link between input and not the occurrence of output, and at the same time, yes, the occurrence of the input and a link with the occurrence of an output, so we have opposite inconsistency here. That is to say, you have to notice that it might be a danger, for example, in my concern. Regarding the artificial intelligence based knowledge, we focus on merge and cumulative artificial intelligence reasoning. So merge is like a neural network based model. That is to say, you have a predefined number of neurons. Each neuron contains a couple, that is to say, a link between input and output, okay, regarding the observations. And when you discover a new input, you are looking for the neural winner, okay? In this neural winner, you have the link between input and output, so that is to say, you can suppose that you will observe the output of the neural winner. And after, you have to manage the knowledge regarding the neighbor of this neuron. For cumulative artificial intelligence process, it's mainly linked to case-based reasoning systems. That is to say, you observe a scenario, you are looking for a similar scenario in new knowledge base, and if this scenario doesn't exist, you can consider that it's a new one, so you implement it into your knowledge. So, now the second phase of the educable learning is the translation of the knowledge coming from natural human reasoning into the knowledge of artificial intelligence. So it's a very complicated process, and I will show you something very simple. So we develop functions that can translate knowledge from the user into knowledge from artificial intelligence. So for both merge and cumulative processes. So that is to say, if you create a new rules that make a link between input and a new output, in fact, you have to identify a link of such input and output into the artificial intelligence-based model, that is a digital model or a numerical model. So here we translate in terms of, to simplify, a binary if you want. So for the digital model, this translation will be done in terms of 0 or 1. And after, you have to transfer this new knowledge here this new link between input and output into the knowledge of artificial intelligence. So, two cases, or it is not a new scenario and you can merge it into the already existing scenario for a merge-based system, or you consider it a new one, so perhaps you have to create a new neuron or to modify the structure of your neuron. For cumulative-based system, it's similar, but it's much more simple. So, here is a transfer for, yes, excuse me, I anticipate the transferring process for the cumulative view, and of course you can observe inconsistency in your knowledge base if in fact you have opposite output that are observed. So I make it in bracket in my illustration, because for my illustration I want to discuss with you about this simple situation. Okay, imagine you have an autonomous system, and it is an autonomous system, and we have all this data to manage. So the discovery process is based on different states: state of the car, the position of the car, the state of the tram, and the gap, because here it's like an autonomous system using adaptive cruise control. Sorry. So you can generate a couple of rules, or the system is functioning. So this rule is based on natural human reasoning, okay? And after you translate this manner to see how the system functions into digital model, numerical model, based on cumulative or merged process. So here you have 5 rules only, taking into account the light here. So everybody knows if the light is green, you stop or you run, except in Vietnam perhaps. So if it's red, I move, okay, and I continue. And the problem, what may happen on this process? So here, yeah, it's a translation in binary, okay, viewpoint of this modeling based on natural reasoning, and here you have a translation matrix that makes you capable to translate the numerical, the digital model into natural reasoning process. So I make a movie to show you what about the possible. Oh, where is it? Oh, okay, it's here. Okay, you recognize the pictures. So the picture here, it's more or less here, okay? And you continue the process. Imagine it is an autonomous system, autonomous car. Without driver, you see, there is no driver. So in this context, there is a possible collision between a tramway and the car. Why? Because the autonomous system, even if it is an intelligent and smart process, implements the rules I showed you before. So the problem is there is a conflict and inconsistency because it is a green light, so I decided to move. But because of a possible collision with the car that is in front of me, I stopped. But I stopped where? On the railway track, on the tramway track. And during this lapse of time, a tramway is arriving, okay, and a collision is possible. That is to say, if we apply the natural human reasoning process, we can generate new rules in the discovery process of educable learning. This new rule can process on the occurrence of a collision, or can modify the rules, and here I did it. For example, instead of put the interdistance between car at 2 seconds, you can increase it, put it in 4 seconds, modify your model, and to see if there is a collision or not. Okay? So the idea here, it is, even if it is green, if I detect possible collision with this car because there is a traffic jam, okay, I anticipate and I decide not to move, even if the light is green. So you see here, educable learning, it is online. or offline, but the concept is validated through feasibility study. So, of course, you understand that we want to develop deeper this kind of new feature for responsible artificial intelligence or trustworthy artificial intelligence. So we propose an architecture for making educable learning possible and apply to human artificial intelligence coevolution. And we illustrate it in a road transportation domain to validate it. So, of course, we want to extend this concept for producing offline on online knowledge processing. That is to say, what I show you here is offline mainly. So how to do it online, it's very interesting regarding all the scenario, an autonomous system or a semi-autonomous with the contribution of the user can discover. And the last one is to produce other case studies. Thank you very much for your attention.
Thank you, Frederic, for this very interesting presentation, very valuable contribution. Some questions, discussions? Okay, we start. Yes. Okay, thank you. Ask questions, please.
Thank you for this presentation. Inductive reasoning or deductive reasoning and the other are based on human intelligence. Do you think one day another kind of reasoning could appear specific by artificial intelligence?
Of course, it's called now neuro-symbolic artificial intelligence. You know that? It exists. So I invite you to, it's a future, but because I discovered it recently. So we spoke about neuro-symbolic expert systems. Natural human reasoning is a symbolic reasoning, and we are speaking about for artificial intelligence, a new concept, again, a new one, a neuro-symbolic artificial intelligence. Very interesting. Yes, I agree. So here, it is an introduction of the possibility to develop such neuro-symbolic artificial intelligence, but it's a new concept.
Frederic, I have a question about the knowledge. Because, in a real knowledge base, there are conflict everywhere. You talk about the inconsistency of rules. I think these rules, inconsistency is more or less related to the knowledge of one person. Another person, probably, he will propose another one. Even for driving behavior, your driving behavior and my driving behavior are not the same. I see the traffic light, as you see on the street. So people have different behaviors. But for you, how AI can deal with that?
Good questions. So, inconsistency between rules implemented in artificial intelligence or a case of modeling of human behavior, whatever. We call them, if there is only one decision maker that has inconsistency between rules of him, we spoke about cognitive dissonance. That is to say, there are inconsistency, is not mandatory to be an error, a human error, but we have to analyze what the danger of such inconsistency. And for example, we assess, we compare the behavior of an SSA, adaptive cruise control and cruise control, in case of aquaplaning, and what about the rule of different drivers with more than 5 years of driving. And the strategy completely different, because the risk of the activated cruise control facing an aquaplaning is dependent on the level of water around the world, but two possibilities, or the current speed decrease and the system decides to accelerate in order to achieve the speed set point given by the driver, or it is the contrary, but it's the same if it is an acceleration of the current speed, the system will brake in order to achieve to make the current speed to the desired to the set point speed. On the other hand, some driver knows that facing an aquaplaning, you do not have to brake nor accelerate. So it is here an inconsistency, dangerous inconsistency, because some driver knows do nothing if you face an aquaplaning because it's dangerous, you can lose the control of your car. So here it's very interesting. So we call here, because we have two decision makers. I don't want to pretend who is right and who is wrong, but here we have to analyze the process in terms of risk. And for, on the other hand, so cognitive dissonance, it's related to cognitive science. On the other hand, organizational dissonance focus on engineering science coming from Galen. He developed this concept about organizational dissonance. That is to say, when you have several decision makers or several group of decision maker, or driver, or user, you can have different point of view. So the idea is to see what is the inconsistency between the two.
Okay. Thank you very much. I think it's really late. Now I think this is the stage of the visit to the laboratory, right? And so for the other presentations, it has been moved in the afternoon. Okay.
Thank you.